All right. Any more questions? Any more questions? Can we pay using cards? Yes, yes. That doesn't matter. Any kind of a payment, that doesn't matter. Sorry? Physical students. Here the receptionist is there. Uh, Anything? If you got any questions other than that, feel free to contact me. I'll solve it by my side. Right? What's your name? No, no. If you made the payment physically, if you are physical student, no need. Right? Yeah, you are getting the link means you can access it through this. Right? Right? That's the thing. So I'll check whether you need to upload this slip or not. I don't think physical students need to upload the slip. Right? Because that's to confirm the payment only for online students. Any other questions? Okay, it seems all good. Right. Okay. So I'll be going back to the lesson. So if you have any questions, any more questions, you can ask. So this is here again. So if you need to register yourself, now you can do it now. Right. This was open since last Saturday. Some students are already registered. So if you haven't registered yourself yet, so you can go here and register yourself, right? Because next week onwards, that's not a precision, no? So therefore, in order to join the class, you have to register yourself there, right? Register yourself there. And about the interface and the using of LMS, I'll explain a bit. That's especially for online students. I'll explain a bit. It's actually very user friendly and it's very self-explanatory. But still, I'll explain if needed. Using any device, you can do it. Using any kind of a device that you have, if you have an internet access, using any device, you can do it. Basically, it's something like this. See, basically, it's something like this. Now, this is the mobile view, right? You will get the same thing on PC as well, right? Same thing. Now here you can see all subjects. If you go in physics, right? If you go in physics, you can see two batches as 26 and 27, right? Then you can go to 27, right? You can go to 27. There the month is visible, right? Month is visible as April, and see, in the description it's here as half months we applied, something like that, right? And go in, and then and the weeks are there, and here you have a button to purchase month, button saying purchase month. So if you go there as the purchase month, you can enter your details in the sense the credentials. You can enter your credentials. You will get a get an email. You will get an email and a password to your account. So you can enter your credentials there and make the payment, right? And in the next step, bank details are visible, right? So you can make the payment. And once the payment is done, you can upload the payslip, and you can send it to the hotline number as well if needed. You can send it to the hotline number as well, but the recommended way is you can upload it there, upload the slip in the LMS. Then once that is uploaded, the registration is done, right? And still, what I'm saying is, since listen, since you are doing this for the very first time, if you have even a minor doubt about anything, you can always contact the hotline, right? You can always contact the hotline number, right? Then there you will assist you, and they will navigate you about everything that you need to do, right? For you also that's same. If you got any difficulty or any doubt about the registration process, anything, feel free to contact the hotline, right? They will assist you. Definitely they will assist you, right? So don't worry about that. And don't hesitate to make a call or drop a message to our hotline number if you have any difficulties, right? Because it's always they are always there to help you out, to assist you. So therefore, don't worry. All right. No questions, no? No questions, right? So I'm moving on. So again, back in the lesson, 7 fundamental physical quantities are mass, length, time, amount of substance, thermodynamic temperature, electric current, and luminous intensity. And their respective units are kilograms, meters, seconds, moles, kelvins, amperes. If any one of you need the word, you can write the word in words as well. This is just a symbol. This is a symbol. Kelvins, amperes, candelas. CD, simple C, that's important. Simple C, simple D. If there is capital C, that's a different meaning, right? That's not candela, right? Simple C, simple D. Candela, C-A-N-C. Candela. 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 Right? Okay, now we are moving to our next step. And this was the last part we discussed in the class, the last class, right? That was derivation of units using these fundamental units. Now, at this point, you know what a physical quantity is, you know what a unit is, and why a unit is used, right? And you know fundamental physical quantities along with fundamental units. Now, our next step is now derived physical quantities are going to be derived using the fundamental physical quantities now. Therefore, we are going to derive some physical quantities here on. Right? We are going to derive some physical quantities here on. How many physical quantities we derived last week? Up to force. Up to force. Okay. See, so I'll explain some examples that we discussed last week. Look at here. Look at here. Let's say, as the first one, let's say we need to derive velocity. Let's say we need to derive velocity. Look at here. This will be the first task we are going to do, and you are going to do today. And this was the first task that we did after these concepts are discussed last week. Right? Let's say velocity. Right? Equation of velocity is change of displacement. First, let me write it in words. Change of displacement over time. This is called a velocity. Right? Now, in O level, sometimes you might have said this as displacement over time, but now you should be more. You have to be more professional. It is not displacement over time. There is change of displacement over time. Right? Those things are needed. Those things are critical when it comes to A levels. This is unlike O levels, but because there are things in O levels, they are like touch and go. But here, all the in-depth things are there. So therefore, please make sure that you are following everything from the steps from here onwards. So therefore, now if you have get used to displacement over time, now this is the time to upgrade to this. This is change of displacement over time. Right? The thing is in O levels, just to give you the idea, the part of the equation is said, right? For this, but this is the actual equation. Change of displacement over time. Velocity is v. Change is denoted by delta. There is a symbol. There is a Greek symbol that is called delta. Right? Delta is for the change or difference. This is the symbol for delta. This is called delta. Delta. There is a Greek symbol delta. Delta means change or difference. Change or difference. Right? That's called delta. Change or difference. So therefore, this is change of displacement delta S over T. Delta S over T. Right? Now, if we are to derive the unit, this is how it's done. Now, when we derive units, we are using simple brackets to say that we are deriving units. Right? That's a standard. The standard of deriving units is we have to use brackets. This is the equation. Now, if I am considering this equation to derive units, this is how the equation should be written. Units of V. Brackets means units of, right? Units of V equals units of delta S over units of T. Right? Brackets means units of. No need to write anything in words. If you put the bracket, which means you are considering units. Units of. Right? Now substitute these values. We are determining units of V, units of V, units of delta S, change of displacement. Change of displacement means a difference of displacements. Right? Then there is also displacement. Right? Displacement is a length. Displacement is a length. Right? Sorry? Sorry? This is the unit, meters. This is the symbol. Yes. Right? Don't get confused. This is the units. These are the units. And here I mentioned the symbols. Symbol of velocity is V. Symbol of displacement is S. Symbol of time is T. Right? Symbols. They are symbols. Those are units. Now only I am going to substitute the units here. Then change of displacement is a displacement. Displacement is a length. Therefore, unit of that will be meters. Right? Over units of time. Time is time, very straightforward. Units of time is seconds. Yes. Then from this, units of velocity is derived as ms minus 1. Units of velocity is derived as ms minus 1. So that's what you have been using already in O levels as well. So this is how the derived unit comes. Right? We are starting from the scratch because we have a way to go. There are more units to be discussed. So we are starting from the scratch. This is a simple one. ms minus 1. So this is how a unit is derived. And this is how the fundamental physical quantities are going to play the role here when deriving units. Right? So either 2 or more, 2 or 3 or any number of fundamental physical quantities will be used in an equation in order to derive unit. Now here, two fundamental physical quantities involved, length and time. So likewise, with the equation, no, sorry, based on the equation, two or more fundamental physical quantities from this will be used inside your derivation, right? So this is simply what it is. This is simply what it is. So last week we discussed about three derivations. I'll be discussing all three now as well because we have to move forward. So therefore, I'll be discussing about all three now quickly. First, tell me if you have any questions about this. Like that means delta with these two. No, that doesn't matter. No, this is what I have get used to. It's not a must write these two. Fine. Now, usually these two are put because sometimes S and 5 will be mistaken. No? So that's why these two are used. Right? Not a must. Right? Questions? So why the brackets are used? Brackets are used to say that we are determining units. We are considering units. Now, otherwise, without this is the equation. Look at here, look at here. Look at here. This is called the equation. This is called the equation. Right? Equation is something we have to plug some values and get an answer. Let's say we have an equation like y equals 2x minus 1. Y equals 2x minus 1. If we plug x as x equals 1, then we will get the respective y value. If we plug x as 2, x equals 2, then you will get the respective y value. So equations are for plug-in values and obtain the results. That's the purpose of an equation, right? Any equation. Purpose of any equation is that. So this is the equation. Equation is to plug values and get answers. But if I'm using that equation to derive units, we have to use this. The idea of bracket is units of. Now, if I read this line, this is how the line is read. Equation is read as V equals delta S over T. This is read as units of V equals units of delta S over units of T. Right? Bracket means units of. I'm going to consider units of the equation. Right? Is that clear? Is that clear? The one who asked the question? Name? Usman. Is it clear? Yes. Good. Right. Any questions about this derivation? All good? Right. Next, let's derive acceleration. Now you can try along with me if you haven't there in the last week. If you were not there in the last week, students who were there last week, you have tried this already, right? If you are not there in the last week, you can try it with me or even before me. Second one, acceleration. What's the equation of acceleration? Second one, acceleration. Change of velocity over time. Now upgrade yourself, don't say velocity over time. Now we have measured distance. Change of velocity over time, not velocity over time. Now if I symbolize this, right, this is the equation in words. Symbolizing means we can use symbols to write the equation. Acceleration symbol is simple A. Right? Change of velocity, delta V, because velocity is V. Right? Delta V over T. This is the equation. Right? Derivation is like units of A equals units of delta V, units of T. Now substitute units. Units of delta V. Delta is difference. Delta is change. Change is always final value minus initial value, right? Any change is the final value minus initial value. Now, if you need change of displacement, let's say when I'm here, my displacement is 2 meters. And if I move forward 2 more steps, let's say my displacement is 4 meters. Then change of displacement is 4 minus 2, final minus initial. Right? Something like that. Any change is final minus initial. Right? In physics and maths, any change, that's a standard. Huh? That's a standard. Any change, any data is always final minus initial. We can't deduct or you can't subtract as you wish. Right? There are standards. If we are getting a change, always the change is final value minus initial value. So this is delta V. Delta V is actually final velocity minus initial velocity. The result is also velocity. Final velocity minus initial velocity. Result is also velocity. Right? So units of velocity is already derived here. I'll be using it at once, ms minus 1. Time is seconds. Right? Therefore, units of acceleration is ms minus 2. ms minus 2. Simple as that. Simple as that. ms minus. Sorry? See, I hope you know these simplifications, indices. 1 over x can be written as x to the power 2, right? Something like this. 1 over x means this is x to the power 1. If you are taking this to the numerator, the power becomes minus. So this is what I used, right? And the other thing is, if you have something like this, 2 to the power 2 times 2 to the power 3, this can be written as 2 to the power 5 by adding these two indices. Right? Now here also the same thing happens. ms minus 1 times s minus 1, no? Then minus 1 minus 1 minus 2. Right? Index simplifications, or we call indices. Even if you have questions about these simplifications, you can ask me. That's all fine. Right? That's all fine. Now, I know this was there. This was a separate unit in O levels. But if you can't recall or if you can't remember, that's fine. Just ask it out. Right? So if we have the same base, indices can be added. Right? So m is minus 2. Okay, all good up to here? Quickly. So, online students, is it all good up to here? Quickly. Yes. Yes. Yeah, even a thumbs up is enough. I mean, if you find it difficult to type yes or no or something, right? Even a thumbs up or a thumbs down is enough. Right? I can see it. Yes. Okay. We are moving on. The third one. Let's go to force. Look at here. And after this last one, after this third one, we'll be moving on to today's things. Now, up to here, I'm still recalling the last week things, right? Okay, wait. Force. What's the general equation or basic equation? Mass into acceleration. F equals ma. Everybody knows, right? F equals ma. That's the general or the basic equation of force. That is mass into acceleration. Right? If I symbolize this, F equals ma. M times a ma equals ma. That's the equation. Now, if we are considering units of force equals units of mass times units of acceleration. Right? Units of force, units of mass, very straightforward because mass is a fundamental physical quantity itself. That's kilograms. Acceleration is determined here. That is already determined, ms minus 2. Therefore, units of force is kg ms minus 2. Units of force is kg ms minus 2. Right? kg ms minus 2. Quickly ask if you have any questions. Simple A. Capital A is used to area, right? Simple K. Right? Now, about these symbols, it's actually coming up in this lesson. They are called prefixes, like kilo, mega, giga, tera, milli, micro, nano, pico. All these things are called prefixes, right? So that there's a separate standard, and that's a simple K. Capital K is used to. Now you have to know these differences. It's a good question you are want to ask whether it's simple K or capital K. In kilograms, it's simple K. Kilo is called a prefix. Kilo is a prefix. right? Something comes up, comes in front of the unit. That's called a prefix, right? So don't worry, that's coming up in this lesson. After derivations, we will be moving to that. And kilo is simple K. Yeah, if you write capital K, it refers to kelvins. It refers to kelvins, right? Now these two are different, no? These two are different. This is kilometers. This is Kelvin meters. Right? Both units are here in A levels. This is called Kelvin meters. Kelvin meters is a unit that you will be seeing in 11th unit, last unit. Kelvin meters. Both units are here in our A levels. So you have to make sure that whether you are writing the correct term. That's why about candela also I explained. Simple C, simple D. That's capital C. It becomes not a unit. That's a what we call cadmium. It's cadmium, symbol of cadmium. Right? They are very important. No? Simple K, when you write kilo, that's called simple K. Another question. So then, what about Newton? It's not. Yeah, I'm coming to that. I'm coming to that. Wait, I'm coming to that. So first, tell me whether are you clear about this? Clear, right? Online students. First, tell me whether this is clear. There is another part to be explained here. Yes. Okay. See, but everybody knows that we are using newtons to measure forces, no? Right? We are using newtons to measure forces. The reason is this. This is a good point. This is a important point. So first, listen. Right? Stop your work and listen. There are some students, some units. There are some students. Sorry, there are some units in our list that they have standard units which are different from the derived unit. The reason is this. Reason is this. There are some units which are labeled as the founder's name, as an honor to the founder. Founding scientist. Founder means the person is scientist, no? So therefore, as an honor to the founding scientist, there are some units. They are labeled. They are labeled as an honor to their finding. Now, as an example, now if I find something, I can establish a unit with the name itself, something like that, as an honor, right? As a credit to that founder, honor or a credit, right? So here also the same thing is there. This is what derives from the standard units, but about the forces, Newton's laws, and all those things, linear momentum, those things, all the researchers were done by Sir Isaac Newton. So therefore, as a credit to that founding scientist, this unit was later on labeled as Newtons. So therefore, we will be using Newtons as the standard unit, not this. When we have a different standard unit than the derived unit, these units are just for the derivation purpose, and they are derived units. Therefore, so this is the first place, the first equation you are seeing such a thing. There are more to come. There are more to come. There are like hundreds of them in our syllabus. There are more to come. This is the first place, first equation you are seeing such a thing. So there are SI units which are labeled as an honorary founding scientist. Right? If you have such a thing, it's a must to keep that SI unit in mind because that SI unit cannot be derived. That is offered as an honor, no? Cannot be derived. So here, therefore, look at here, this is important. SI unit of SI means standard international. SI unit of force is newtons. SI unit of force is newtons. Newtons. As an honor to Sir Isaac Newton. So therefore, newtons is exactly equal to kgms minus. Newtons is exactly equal to kgms minus. Right? So either way it works. If you have kgms minus 2, we can write newtons is, if we have newtons and if I need to expand the term and see what's inside, we can expand it as kgms minus 2. Right? So this is called the SI unit. Now this is how this works. When we have multiple units, only one SI unit is the quantity. C is the SI unit. This is SI unit. This is called the derived unit. This is called the derived unit. This is called the derived unit. This is how it comes. Understood? I hope I answered the question that's asked by you. Who asked that? So then what about it? Yeah. Dilukshi. Right? I hope I answered the question, and still if it's not clear enough, tell me. Is it not clear? Yeah. Is it clear? Clear enough? Yes. Right? So when we have such cases, it's a must to keep this in mind, because you can't derive this if you don't know Newton's. If you derive, you will get the derived unit. Right? Not the standard unit. If we have a standard unit, definitely we have to keep it in mind. Right? Okay. So that was the last equation we discussed last day, right? Okay. Then now we are good to go with today's things. We are good to go with today's things. And I can remember that I gave you some parts on you to try out, right? But before going to those discussions, I'll be discussing the derived units here, and we'll be going to the field, right? Okay. Any questions up to this point, right? Now, if you have understood up to here, which means you are all good to proceed with today's things, right? But still, I recommend you to go through the recording later on after the class, right? Because here I explained these things in a faster manner, because this is just a revision kind of a thing I did, a recording, right? So I explained more in depth in the first class. So always I recommend you to go through the recording. And even if you have missed first two sessions, even for this one also I will be sharing the recording, right? If you missed, I mean, if you have any friends or something, I'm saying this, right? If you have any friends or something that who are still willing to join to the class, and if they are worrying about the first two sessions are missed, that doesn't matter, because I'll be providing the recording of these first two sessions once he or she is coming to the third class, right? The third session, right? So therefore, that's not a problem, right? And anyway, after you registered, you can access any recording. You can access any recording during the month, right? Any questions up to here? All good? All good? Online students? Online students, any questions? Okay, it seems good. All right. Good. Good. So let's move on. Let's move on. Now we've had the third derivation, right? Now we are moving on to the fourth. We are moving on to the fourth. Now, if you have missed the first day, how many pages roughly do you have? Okay. How many pages? 2.5. Right. Roughly, for the things we discussed up to this point, roughly 2.5, 3 pages are gone. So therefore, what you can do is in a CR book, 3 pages. So left 3 pages in front, then you can complete your note on those 3 pages while going through the recording, right? And then you can start today's things here onwards, right? And I recommend you all to use a CR book for physics especially, and if you are doing maths also. Now that's very common when it comes to A levels, because otherwise, if you are using what we call an exercise book, that won't be enough, because in physics also we have more diagrams, more simplifications. Then it won't be enough. I mean, managing space is kind of difficult when we have a small exercise book, right? So therefore, I recommend you to use a CR book if you haven't purchased any book yet, but if you have already purchased an exercise book, now you can do the first unit 10 of those things in that exercise book, and when you purchase again, when you buy a book again, you can buy a CR one, right? Because that's easy to manage space. That'll be more clear to you, right? Okay, so if you were absent last week, repeating again, listen. If you were absent last week, you can start from this point onwards, right? And for the note, you can keep 3 pages of a CR book roughly 3 pages, right? As an average 3 pages. If you feel like you need more with your font size and all that, with a buffer you can keep more space. If you feel like you can manage with three, I mean roughly three, yeah. 3 pages. Okay. Now we are here. 4. Let's go to work. Work. I know this equation is there in all. The equation of work. What's the equation of work? What's the equation of work? Equation of work. You should remember you are just after hours. Force into displacement. I'll be writing the same here. Right? 4. Work. Yeah, that is correct. Force into displacement. Right? Force into displacement. Sorry? Sorry? Change of displacement. No, displacement. Right? Force into displacement. Here the displacement is parallel displacement to applied force. Right? Parallel displacement to applied force. Now, I'm not going to explain more about the application of the equation because here it will be in the derivation of units. No? About these equations also, they are actually coming up. We have a separate lesson coming up in unit 2. We have a separate lesson coming up as energy and work. So there we'll be discussing about all these applications in detail. Right? Here this is just units. No, this we are studying units and dimensions. So this is all about units. So therefore, I'll be explaining more about the units aspect of this only, right? Otherwise, don't think about or don't worry about actually application of the equation, right? Applications are coming up. I'm here using all these equations to derive units, right? Derive units. Work equals displacement, force into displacement. Now, if I symbolize this, work is W. Right? Force F, displacement S. W equals Fs. Equation is W equals Fs. Right? And sometimes the same equation is written as F into D as well. If we write D here, the idea is distance, not the displacement. Right? But distance and displacement will be equal if and only if it's linear. If not, they are not equal. So therefore, this is the exact equation you have to follow. Displacement. If you have get used to distance, that is not the distance. It has to be displacement. But sometimes I have seen O-level students who are saying force into distance, but it's not the exact equation. That is valid only for straight lines. Otherwise, it's not. So therefore, don't write FD. It's not wrong if you write FD. But we are using D for distance. S for displacement. Now we have to have a separation between displacement and distance as well. No? That's why S and D are used as a standard notations. Fs. Okay, now you can derive this. Before me, derive units. And listen. If there are multiple units, listen. If there are multiple units, right, more than one unit, you can derive all of them and label them as 1, 2, 3. 1, 2, 3, 4, whatever the number you have, you can label them one by one, right? Because here actually there will be multiple units. Give it a try before I explain it. Give it a try. Determine units of W. Give it a try. Give it a try. And if you get any answers, you can say it out, or you can put it into the chat box. Correct. There are more units as well. And, yeah, we are getting answers. What about you? Correct. Kg m square is minus 2. Correct. Now in the chat and the class also, I can see now students have got different answers. That is because there are more than 1 unit possible here. That is because there are more than 1 unit possible here. That's why now all of your answers are correct. Kgm is minus 2 is correct, and I see Newton meter. That's also correct, right? So that's why I told you if you have multiple units, you can label them as 1, 2, because when except the standard unit, all other units will be derived units, right? No, Kgm is minus 2 is newtons, then you can substitute this to newtons and simplify again. Yeah, newtons can be expanded as this is Newton meters. Newtons can be expanded as this. Then once you expand newtons as that, simplify again because it should be multiplied with meters, no? Then you will get the next one. That positive. Okay, look at here. Look at here. Time is enough. I'll be first. Look at here. First, force no. Now for force also, I know we have two equations. You know, we have two units. But I'll be first starting with the SI. Right? I'll be first starting with the SI and moving forward. Right? Now this will be, look at the board, units of force times units of displacement. Right? Then units of force is newtons, SI unit. And units of displacement is meters. Right? Then from this, we are getting Newton meters. We are getting Newton meters. That is acceptable. That's a possible unit. Newton meters, possible unit. Right? But newtons are more expandable. Newtons are more expandable. So therefore, if I expand newtons, I will get another unit. Right? Both are correct. Both are correct. I'll get another unit. Newton meters. No, this is actually the first unit. Right? This is actually the first unit. First unit. And now I'm going to expand the same equation. Look at here. Same equation. Now that's Newton meters. Now I can expand newtons as here. Newtons is kgm is minus 2. Now instead of newtons, I can use kgm is minus 2 times meters, which is coming from here. Right? Now kg m into m is an index simplification, m to the power 1 times m to the power 1, that will be m square, m to the power 2, m square. Right? Then kg m squared is minus 2. This is another unit. So let's say this is 2. That's another unit. So both are acceptable. So I show both answers. In your answers, both are acceptable. Both are the possible units for work. Both are the possible units for work. When we have derived units, you have to derive all derived units, right? And after here, check again whether this is further expandable. So this is how you can make sure that you have acquired or you have obtained all units. Kg cannot be expanded further, kilograms. It's a fundamental one, no? Meters, fundamental. Seconds is also fundamental. Now, if these units are within the fundamental units, which means you can't expand it further. That's it. In the fundamentals, right? But here this is not fundamentals. Newton's is not a fundamental unit, which means it is expandable, which means it is breakable, expandable. So that's why I can expand. But if you check here, kg is fundamental, meters is fundamental, seconds is fundamental, which means it cannot be expanded further on. Have you entered this? All right. All right. Have you got these answers or any question about these two? Any question about these two? Newton meters. This is called kg m squared is minus 2. Kg m squared is minus 2. All good? Online students? Any questions? I'm always happy to hear your questions if you have any, right? No need to keep them in mind or just proceed with the doubts if you have any. Feel free to raise the question and get it clarified. Now, that's the ultimate purpose of learning here, right? Now, if you are leaving the class with doubts, that's not the case, right? Or even after the class also, if you have something urgent, you can contact me via a direct message or something and I can still answer. But if you have any doubts within the class, during the class, you can easily clarify them during the class and leave the class. Online students, I didn't get any response yet. Are you with me? Are you all good about these two? Yes. Good. Good. Others? Okay, good, good. Right. Good. But the beauty is, standard unit of work is none of them. What's the standard unit of work? I know you know this unit, right? I'm 100% sure that you know the unit. Tell me. And I will give you a hint. I got the answer. Good. Yeah, that's correct. Others? Good, good. What's the standard unit of work? Then I'll give you the hint. I got the correct answer from our student. Yeah, the hint is standard units of both energy and work are same. Standard units of both energy and work are same. Then what's the SI unit of work? Yeah, joules. It's joules, right? So therefore, SI unit of work and energy both are joules. Like look at here, SI unit of both of them joules. And the notation now the symbol is capital J. Symbol is capital J. Joules. Therefore, now this is the idea. This is the idea. Look at here. Don't write anything. I give you the note. Don't worry. Joules equals Newton meters. And that equals kg m squared x minus 2 as well. Now, altogether, we have three possible units. Three possible units. Huh? Altogether, we have three possible units for work. Three possible units of work, but the SI unit is joules. Only one SI unit for a given quantity, and all others will be derived units. Now here, it's like this is SI. This is SI. And both of them are derived units. Both of them are derived units. That is how it goes. Right? Now, don't write this yet. Right? Now, below this, use a red pen and with an asterisk mark, put an asterisk mark and write this down. Right? Don't I have red pen? Use a red pen and put an asterisk mark and write down standard unit of bring a red pen next day, right? But the standard unit of I'll be writing all important points in red, right? So therefore, if you are the purpose is this, listen. The purpose is this. Now, if you are skimming through the note, skimming means if you are quickly going through the note, right? Just go through what is written in red. It will recall everything that you need to know. If you need to go further in detail, then you can check these indications and all that, right? Now, always throughout your note until you are in my class, we'll be writing special points in red, right? Those are the points, the key points that are important when you are skimming through the note, right? Okay, but the standard unit of work slash energy, work slash energy, but standard unit of work slash energy is joules. Joules. First, write it in words is joules. J-O-U-L-E-S, joules, and write this within brackets. Within brackets, capital J. Within brackets, capital J. Right? Now keep using the red pen and mention this in red and highlight this. Highlight means you can either highlight or you can square this, right? Now, these things are important for your conversions. Conversions in the sense, now at any unit conversion, if you need to convert joules into its derived units, you can use these equations to convert it. Right? You will need such cases in the future. So that's why this is important. You have to know what's inside joules. Joule is also the name of the founding scientist. Right? That's a name. Because that's an honored unit. That's a unit offered as a credit. Joules. Scientist's name is Joule. Right? All clear up to here? Is it all clear up to here? Okay, we are moving on. Right? We are moving on. Five. Here. Five. Power. I know this equation is also there in O levels. Anyone knows the equation of power? Anyone who knows the equation of power? Correct. Online students? Anyone who knows the equation of power? Work over time. Acceptable. Correct. Correct. Work over time or energy over time. Because work and energy are same. Right? Same in terms of units. Right? Okay. So I'll write it as energy over time. Even if it's work over time, that's acceptable. But generally, that is energy over time. Energy over time. That is energy over time. Right? Okay. If I symbolize this, if I convert this to turn this to symbols, power is P, energy is E, time is T. So power is E over T. Everything. Right? T equals E over T. Now this is equation. Now I will give you 2 minutes. Quickly derive all units. Quickly derive all units. And at any point, if needed, you can expand energy as well. Because before also I mentioned that energy and work are same in units. That's same. So in every aspect, energy and work are same. Right? The difference of energies are called work. The difference. Right? Difference of energies are called work. Right? So if needed, at any point, you can expand this energy as work as well. That's totally fine. So derive all units and tell me how many units you got. And tell me how many units of you got all together. And yeah, you can put those units to the chat as well. I can read it out. When it comes up, always the index becomes negative. Index becomes negative. Now, if there's nothing here, that's 1. Right? Then that 1 becomes negative 1, minus 1. Two derived units. 2. Okay, let's see. Others? Correct. Good. 3 derived units. Okay. Okay, let's see. Let's see. Right now, students are getting answers. Yeah, good, good, good. Yeah. 3 again. Yeah, good. Yeah, now I can see that you are getting answers. Okay, I'll start my discussion. See, power equals energy over time, right? Then units of power equals units of energy over units of time, right? Okay, units of energy. Always I'll be moving with the standard towards the fundamental units. Then I can make sure that I won't miss anything. That's the idea, right? So don't substitute units here and there. Then you don't have any idea about whether you have missed any unit, right? So therefore, as a practice, right? As a practice, you can start from the SI and then stepwise break it down. And then finally, if you have stopped unit simplification at fundamental units, it means you have covered everything, right? So I will be starting from the SI. SI unit of energy, joules. SI unit of energy, joules. SI unit of time, seconds, which means there is Js minus 1. J is minus 1. So this is 1 unit. J is minus 1. And then we can expand joules. I have erased it from the board. We can expand joules as Newton meters. Simply. We can expand joules as Newton meters. Right? So here, second one, I can expand joules as Newton meters. Always. Right? Then from this, it comes to NMS minus 1. This is also a possible unit. Let's say 2. That is also a possible unit. Now check the final unit again. NMS minus 1 newtons is not a fundamental unit, which means that is further expandable. Meters is a fundamental unit. Seconds is a fundamental unit. So which means only newtons can be expanded from this. Right? Now I'll take this to here. Right? I'll take this to here. Now E equals NMS minus 1. I can expand newtons kg ms minus 2. We proved it already. Kg ms minus 2. And here another ms minus 1 is here. Newtons ms minus 2. Now go back to the first or the third derivation and take it out. Kg ms minus 2. Right? Now simplify this. Only 1 kg term here. So kg here m to the power 1. This is also m to the power 1. Which means m squared. S minus 2 times s minus 1. These two will be added. S minus 3. Right? So this is kg m squared s minus 3. That's the third unit. That's the third unit. Kg m squared s minus 2. Third unit. No, m is minus. This is correct. See, the substitution is correct. Kg m is minus 2. Right? This is joules, not newtons. Joules? I expanded newtons. See? I expanded newtons. Newtons is kg m is minus 2. Now, if you are substituting joules, you can substitute it here itself. If you are substitute for joules, but I said I didn't substitute these things here and there. I'll be starting from the standard then breaking down stepwise. Then we don't miss any unit. Yeah, correct. Correct. Yeah. Now you have missed this one. No? The reason is that. That is why I break these things from starting from the SI. Right? You also can make it a practice. You can start from SI and break it down step by step. Right? At once, don't substitute joules because then you will miss this unit. Right? Go stepwise. Joules, then joules into Newton meters. Second step. Then newtons into this. Then we can make sure that you have got all three. Because now, if you substitute from here, there is a possibility of missing the intermediate units if there are any. Now here, that's there. Yeah, 3 units. Yeah, good. Are you all clear about how these 3 units are derived? Are you all clear about how these 3 units are derived? Yes. Online students? Yes. Okay. Good. All right. But the beauty is that SI unit of power is also none of them. SI unit of power is also none of them. What is SI unit of power? What is SI unit of power? I know you have come across that as well in O levels, and in this classroom also I can see that. I can see that unit. SI unit of power. Yeah, watts. That is again an honored unit. The founder was watt, right? So therefore, SI unit is watts. SI unit is watts. Look at here, don't write anything. Don't write anything. SI unit is watts. Capital W. SI unit is watts. Right? So therefore, don't write. Therefore, watts equals joules per second equals Newton meters per second equals kg m squared is minus 3. Don't write. And this becomes the SI, and all three here are derived units. All three are derived units. So therefore, all together we have 4 possible units for power. 4 possible units for power, and 1 being the SI and 3 being derived units. Altogether 4. Right? There are physical quantities which are having more units like this. Right? More units. They are called derived units. Okay. Now, again use the red pen with an asterisk mark, put an asterisk mark and write down. But SI unit of. But SI unit of. But SI unit of power is watts. First writing words. But SI unit of power is watts. Within brackets, capital W. Watts. Within brackets, capital W. The question. Does the question specify which unit to use? By default, we will be using a standard unit only. Right? Let me answer that question. Listen. Give me a minute. I will finish this sentence and come there. What did I say? But SI unit of power is watts. Within brackets W. And then mention this and highlight this. W. So, meaning is different. Now that's a special case. Symbol of work is also capital W, right? And unit of watts is also capital W, right? Now in such cases are also there. In such cases, we have to be contextual. According to the context, we have to know it. Right? So highlight this, highlight or square this. Right? What being SI and all other 3 being derived units. Altogether 4 units. Altogether 4 possible units. And the question, back to the question. Okay. Listen everyone. Does the question specify which unit to use? One student asked whether the question specify which unit to use. Listen. This is the rule. This is the rule. The rule is always we will be sticking to SI unit, right? And if the question is specifically saying you to derive all other derived units, then you have to derive other derived units. Otherwise, if there is not a question about deriving units, we will be stick to the SI unit, right? That is how it is. That is how it is. And in units, you will be getting questions to find out derived units. Then you have to find out all derived units, whether it's 3O, 4O, 5O, any number of derived units. If you have to find it out all. If not, if you are using it in our day-to-day work, we will be using this standard unit. Right? Now, as an example, if you are measuring a force, let's say the applied force on this pen is, let's say applied force on this pen is 10 newtons, right? We will be referring this as 10 newtons, not 10 kg ms minus 2, Right? Always will be stick to the standard value, standard unit. But if needed, you should be able to, you should be able to expand the unit. Right? If a force is given, you won't be given the force as 10 kgm is minus 2. No. Always in the question, if you are getting a force, it will be given as 10 newtons, 20 newtons, 50 newtons, something like that. Because always you will be sticking to the SI unit. Right? But all units are important for expanding and derivation purposes. Right? Is it all good up to here? All clear up to here? Okay. Any more questions? Or is it all clear? Now it's okay, right? Audible, right? What I was asking is the general equation of pressure. What is the general equation of pressure? General equation of pressure. Simply, that is force of area is correct, but that is actually perpendicular force of area, right? Perpendicular force of area, right? Now, if you have such kind of, I know in O levels, the equation, if you know the equation from O levels, you will know it as force over area. That is what I expected. But now the exact equation will be upgraded the exact equation. Exact equation of force is perpendicular force over area. Right? So update yourself. Now we are in A levels. This is actually perpendicular force. Not just a mere force. This is a perpendicular over area. Perpendicular force over area. Right? Perpendicular force over area. Don't say HOG. HOG is the hydrostatic pressure. I asked about the basic equation of pressure. General equation of pressure is perpendicular force over area. Right? HOG is the hydrostatic pressure. Right? That also will be proved in hydrostatics. That is also proved using this general equation. This is the general equation of pressure. HOG is correct, but that is about hydrostatic pressure. That's a form of pressure, not the general equation. I asked the general equation. Okay, if I convert this to labels, pressure is also P. Now, There are some cases like that as for power also we are using capital P. For pressure also we are using same P. It's contextual. Pressure is also P. Perpendicular force, capital area, capital A. Don't write simple A. Simple A is exclusively for, sorry, capital F. Simple F is used for frictional force as a standard, right? Except frictional force, for all other forces, uh, by default we'll be using capital F, right? If you write simple F in units and dimensions, that is not that critical. But when we are moving to lessons like friction, in friction that matters because for frictional forces we will be using simple F, while we are using capital F for applied forces, right? So therefore, this is also capital F. Try to derive this. I'll give you 2 minutes. I need you to derive all derived units. I need you to derive all derived units and tell me how many derived units you got. And if you have any questions, you can ask always, right? Any other questions? Two derived units. Any other questions? Please ask if you have anything, because that is an advantage, that is an opportunity that you can take. Area. What is area? Derive it. What is area? Area is, what's the general equation for area? Let it be. Finish. Okay. Two derived units. Okay. Sorry. Okay, you are saying two. Yeah, what are the two units namely? What are the two units namely? What are the two units namely? Nm minus 2. Okay, 1 nm minus 2, correct. And kgm minus 1 is minus 2, okay. Newtons will be kg ms minus 2. Okay, time is enough. Let's see. Okay, let's see. Time is enough. So right here, units of pressure equals units of force or units of area. Right? Now, if you don't know units of area, you can get it done somewhere else. See, this is for you if you don't know units of area. Go to basics. Area is length into width. Area is length into width. Basics. Area is length into width. Right? In which case this equation is taught. Area equals length into width. Before 5, right? Yeah. 3 or 4, something like that. Before grade 5. That is the general equation or the basic equation of area. Right? So don't think of pi r squared or something like that because those specifically for circles. General equation of any area is length into width. That's it. Right? Area is A. Then units of area will be units of length. Units of length. Length is meters. You can derive if you don't know this. This is not mandatory. If you know units of area, you can plug it here at once. Right? This is for you if you don't know units of area. Width. Width. Width is also length. Width is also length. Right? Measured in meters. So therefore, units of area is square meters. Is square meters. Right? Use it here. Force is fundamentally as newtons. Area as m squared. Simplify this, then you will get nm minus 2. This is a possible unit, unit 1. nm minus 2. That's a possible unit. nm minus 2. Got it, right? Simplification errors. When this comes up, nm minus 2. Be mindful with your simplifications. Now it's correct. Right? Be mindful with your simplifications. Okay, nm minus 2. Now check whether this is further expandable. Right? Check whether this is further expandable. Newtons and n minus 2. Meters is a fundamental part. But newtons is not a fundamental unit. Which means newtons are further expandable. So I'm going to expand this. I'll do the rest here. See, I'll do the rest here. Now I have to look at the board. If you didn't do this integration, look at the board. Nm minus 2. Newtons can be expanded as kg ms minus 2 times minus 2 now. Right? This part is for newtons. Simplify this again. kg m times m minus 2. Right? M times m minus 2. It will be added plus 1 minus 2 means minus 1. Right? M minus 1 s minus 2. M minus 1 s minus 2. This will be another unit, unit 2. kg m minus 1 s minus 2. Right? Okay. Two derived units, good. Right. You have got both of them. No? If you have any changes, you can check it mine and make those changes. You can correct those changes if you have any changes. Right? N minus 2 and kg n minus 1 is minus 2. But what's the standard unit? What's the standard unit of pressure? What's the standard unit of pressure? Yes. Yes. Yeah. The standard unit of pressure is not ATM. ATM is a reference unit. Right? Now, sometimes for referring purpose we are using ATM. Atmospheric. That is not the standard. And PSI is also not the standard. Sometimes you might have seen PSI. Pascal is the standard. Pascal. Right? Pascal, capital P. With red pen, write this down. With red pen, write down. But the standard unit of pressure is, but standard unit of pressure is but standard unit of pressure is but standard unit of pressure is pascals. But standard unit of pressure is pascals. This is how the spelling is pascals. But standard unit of pressure is pascals. Capital P within bracket capital PA. Right. Capital P simple A. Pascals. Okay, now you can mention all these things together. Pascals equals Nm minus 2 equals kg m minus 1 s minus 2 and highlight those values. Grab all these things from the very beginning. So therefore, I mean, it will be very easy when you move forward in your journey. If you are grabbing these things from the very beginning, it will be very easy to know. The reason is our outline of units and these lessons are in some kind of an order. That is how it should be. So therefore, starting with units and dimensions, we are moving step by step. And all these things are connected with the flow. All these things are connected with the flow. Therefore, when we move forward, all these knowledge on units, dimensions that is coming up, and measurements, they are coming up. Those parts will be needed. That's the flow. That is how it goes. Right? You are not going to be like in middle of sea. I mean, in the middle of sea out of nowhere. It's not the case. We are starting from the step, and there's a logical flow here. Once you grab everything from the beginning, you can go in that flow smoothly. When you have that smooth flow, you can easily be in this A-level journey. Right? That's the beauty. So therefore, grab all these things from the beginning, then like smoothly as step by step, stage by stage, we can go on. That's how logically the order of the lessons are. Right? Okay, next one. Right? I hope there are no questions up to here. Right? If you have any questions, no need to wait until I ask whether you have a question. You can always question me about it. If you are physical, you can just raise your hand and ask it. If you are online, just put it to the chat. I can see it from the chat. Right? Okay, next. Seven. Seven. Linear momentum. Write down in words. Linear momentum. Write down in words. Linear momentum. I know that's also in O levels. Anyone who can remember the equation by any chance? Linear momentum. No, no. I'm not going with the flow of the tube, right? I'm not following the flow of the tube, right? So I will give you those things to practice again in the tube, right? I'm not following the order in the tube now. So don't refer the questions I have given on the number one. Still, I'm explaining the concepts here. Then after this is done, I give it to you to try. Right? Don't worry about it yet. Yeah, I got the correct answer from our student. Linear momentum. Now it's just 2 weeks after all of us, huh? You know. You must remember technically, but it doesn't matter. You must remember. Today is 10th, yeah, exactly 2 weeks. You finished all levels on 26, right? Yeah, mass into velocity, right? Linear momentum is mass into velocity. Mass into velocity, right? Linear momentum is also denoted by P, right? Linear momentum is also denoted by P. P equals mv. This is the equation. Okay, find all units. Find all units. Yes. And so, momentum. Moment. That's different. That is mr square. That is called moment of inertia. You ask force moment. That is also different. Force momentum, linear momentum are different. This is momentum. Force moment means F times D. Force into perpendicular distance. Force moment. Momentum is mv. Meaning, let me explain this way. This is also coming up in Newton's laws. I hope you have done Newton's second law in O levels. Right? The second law in O levels. Right? Idea is momentum per unit time actually. Momentum per unit time is the external force applied on a system. Right? Just know, I mean, that is enough for now. Newton's laws is also a part coming up. So there will be explaining about these things very much in detail. Otherwise, momentum means motion, mv. If there's mv, that's a momentum, that's a linear momentum. Correct. Yes. Okay. Units of momentum, units of mass into units of velocity. Very straightforward. Units of mass, kilograms. Units of velocity we have determined before. One. So this is kg ms minus 1. This is in the standard, the fundamental units. It can be expanded further. kg ms minus 1. Right? And I hope everybody has got it. Right? That's very straightforward and simple. Kilograms into velocity, m is minus 1, kg m is minus 1. Kg is a fundamental unit, m is fundamental, s is fundamental, so it cannot be expanded further. It cannot be expanded further. Right? Okay. Next. Next. Kinetic energy. So number 8. 8. Yes. Sorry. This is a unit. This is a unit. Now, if there are only one unit, it will be this is a unit. Right? This is a unit. kg m is minus 1. If there's only one unit, definitely it has to be the same. Only one, no? And 8, kinetic energy. Very popular equation. What's the equation of kinetic energy? Half mv squared. First write the equation in words. Half times mass into velocity squared. I'll also write it here. 8. Kinetic energy. Half times mass times velocity squared. Symbols are for kinetic energy. We use Ke, half mv squared. Sorry. Sorry. Symbol of momentum, VOV. Symbol of momentum is P. Are you asking about linear momentum or velocity? What's the velocity or momentum? No, someone asked the question. I didn't get the question, that's why I explained. Are you asking about the symbol of velocity or momentum? Velocity. Velocity, for velocity, simple V and capital V both are used. That's not critical. That's not a problem. For velocity, both are used. Right? For derivatives, any other questions? Yeah. Right. This is a number, right? I didn't explain. I didn't explain. I just uh, leave you to do this. What about the number? What about now? This is the idea. Look at it. I'm not going to discuss this. I'm going to give you some hints on this. Now, kinetic energy, units of kinetic energy has to be units of half into units of mass into units of T square. No? Half is a number, or we call it a coefficient in maths. Coefficient, right? That's a number. Coefficient is a number, right? What's the unit of a number? I need the answers from your side. Think of some practical scenario and tell me. What's the unit of a number? Number means, to be more specific and to be exact, that's called a coefficient. What's the unit of any coefficient? What is it? That's not a unit. Yeah, I got the correct answer. Unit less, no unit. For a number, no unit. Take our number series. The number series is from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, these numbers. No unit. No unit. Right? No unit for numbers. Unit is for the physical quantity, not for the numbers. Right? Unit is for the physical quantity. Now, if I say 1 meter, that is because of length. Length is the physical quantity. Numbers are unitless. Numbers are unitless. There are unitless quantities. There are unitless quantities. This is the very first occasion that you are seeing as unitless. There are more to come. There are unitless cases. There are more percentages, fractions. There are more ratios. All are unitless. So numbers are unitless. I will give you the note after this. Numbers are unitless. I will give you the note. Now keep that in mind and do this. Numbers are unitless. Listen, another thing. When you have unitless term, when you have a unitless term, uh, you can skip that term because that unitless, no? Right? So therefore, I can write this equation in this way. See, units of kinetic energy equals, if there are no units for the number, it is not contributing in the units. So therefore, this can be written as units of mass times units of this, you know, because number is unitless, right? This is not the equation, no? Equation is this. If we are determining units, now I have converted this unit. The units of half is unitless. So therefore, we can skip it for a moment and write down this part. Or else, there are two ways. Or else, uh, if needed, or else if you have a unitless quantity, you can consider unitless quantities as one. That is also another practice you can have if needed. Because if you write one here, it doesn't change the equation. So therefore, at any time, any unitless quantity can be written as one as well, or else easily or simply you can skip that quantity. Doesn't matter. Both are same. Both are same. Okay, now what's the unit? Check it again. You have some. Okay. See, numbers are unitless. That's a learning. That's a learning. Okay. Kinetic energy. Mass is kilograms. Velocity is ms minus 1. Whole thing squared. Simplify this. kg. This is an index simplification. Whole thing squared now. So this square belongs to both of them. Then m squared comes and s minus 1 into 2 minus 2 comes. Right? Simplify this. Then kg m squared s minus 2. This will be the unit. Kg m squared is minus 2. This is something we have got before as well. What was this? Kg m squared is minus 2. We got this before for what? We got this before for work. We got this before for work. Right? So there also I gave you a point as standard units of work or energy as joules. So therefore this is exactly equivalent to joules because this is an energy. Any form of energy is measured in joules. Any form. Right? There are multiple forms of energies: kinetic energies, potential energies, strain energies, heat energies, sound energies. Anything is measured in joules. Right? So we wrote it before as well. So therefore, for this also, all units that we derive in work are possible. All units that we derive in work are possible here. Right? Okay, again use the rectangle and write this down. The standard unit of or SI unit of the standard unit of SI unit of SI unit of any form of energy, SI unit of Any form of energy. Any form of energy. Because there are multiple forms. Right now, by now, basically you should know about gravitational potential energies and kinetic energies. But there are more forms other than those two as well. There are more forms of energies. But any form is measured in joules. What standard unit of any form of energy? Any form of energy, not kinetic energy, any form of energy. Energy E. If you write K, that is about kinetic energy. What I said was, but the SI unit of any form of energy, any form of energy is joules. Any form of energy, sorry, any form of energy slash work, any form of energy slash work, any form of energy slash work is joules, is joules, is joules, right? So therefore, this is valid here as well, right? At work, I explained this. Joules equals Newton meters equals kg m squared f minus 2. I explained this in work. So this is exactly right here as well. Right? So simply keep in mind that work and energy are same in every aspect. Work and energy are same in every aspect. In each and every aspect, they are same. Okay. Right. Next one. We are moving on. Next one. Gravitational potential energy. So number 9. 9. Gravitational potential energy. Gravitational potential energy. Gravitational potential energy. Now, before the calculation, since it is also a form of energy, definitely you should get joules, right? Joules or any other derived unit of so that's a form of energy. Right? Knowing that, do your simplification. Put down the equation. What's the equation of gravitational potential energy? mgh, right? mgh mass into gravitational acceleration into vertical height, right? First write the equation in words. The equations are for your reference, for your future reference. That's why I'm encouraging you to write the equation in words. First of all, this is gravitational potential energy. There is mass into gravitational acceleration into vertical height. Into vertical height. Now in the tube I see there's a type over there that is not vertical height, that is the vertical height. You can make that correction in the tube, right? In the tube number 8, that is not vertical, that is vertical. Vertical height. Vertical height. Vertical. I write it here. Vertical height. Vertical. Vertical height. Only R is missing, not vertical, only R is missing, right? Vertical height is strong, right? There E is missing. There's a typo there, right? So if needed, you can make the correction. That's vertical height. Okay, this is the equation anyway. And symbols are for gravitational potential energy, we use PE. 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 For normal general energies, we use E. But if there is specified as kinetic potential, we write it as KEOBE. E is MgH. Okay. Do the calculations. Do the calculations. Okay. Put it. Okay. It's not a big deal. Potential energy. Units of potential energy is units of M. Times units of G. Times units of H. Units of mass. Kilograms. Units of gravitational acceleration. Gravitational acceleration means an acceleration. Right? There is an acceleration. Ms minus 2. Vertical height. Height is the length. So that is meters. Right? So still you are getting the same kg m squared is minus 2. Kg m squared is minus 2. So therefore, it's exactly same as before again. This is also measured in joules. Right? This is also measured in joules. So for here also, this same thing is valid. Therefore, joules equals Newton meters equals kg m squared is minus 2. That's same for any form of energy or work. So therefore, standard unit or SI unit of potential energy will also be joules. That is joules. Right? So I'm not going to mention the same point again because now we have mentioned it already. So that is also same. That is also same. Right. All right. Any questions up to here? Any questions up to here? Now we have completed how many? Nine. Nine derivations of units altogether. Out of the nine. Any questions up to here? Is it all clear? Yes. Online students, is it all clear? You can always ask if you have anything. You can always ask if you have anything. If it's all clear, say it's clear, or at least a thumbs up. That I didn't explain in the class yet, right? Okay, all good. Right. Okay. Now I will give you a small task as a homework. Write this down. That is not in the note. Write this down in the book. This is a question, huh? This is a question. Take this down. This is a question. Take this down. Find all possible units for 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 energy per unit volume. Energy per, write down it. Per energy per unit volume. Energy per unit volume. Write down all possible units for energy per unit volume. Energy per unit volume. Okay. If such a question is given, now first you have to convert it into ratio. It is a ratio. Energy per unit volume. Let's say energy is V and volume is V. How we can write it as a ratio? How can we write it as a ratio? Energy per unit volume. I hope you are familiar with this equation. Density equals mass over volume. Right? So how this ratio is stated, or how this ratio is said? Mass per unit volume. Right? Mass per unit volume. Per means that's always coming in the denominator. Rho density. Right? So likewise, the idea is if you have something like per in ratio, it is coming as the denominator. It is coming as the denominator. Right? Something like this. Let's say we have something like x over y. This is x per unit y. This is called x per unit y. X per unit y. Always per, the quantity of the symbol with per comes as denominator. Right? So that's how our ratio is written. So therefore, right, I said energy by unit volume. No? Then energy by unit volume is energy over volume. E over V. This is called energy by unit volume. Right? That is called energy by unit volume. Okay. No. That is M over V. This is E over V. Right? Right? So here, what I just gave is energy per unit volume. Energy per unit volume. So ratio is E over V. Right? So keep this written, and then hereafter we will find out the units since the equation is known. And likewise, sometimes you can get a question just in words. If you got the question in words, first you have to convert that to equation like this, and then only you can do the units there. Then only you can do the units there. Right? Okay, I'll take it to you as a homework. Right? And I need I said all units, right? I said all units, no? Okay. I need all possible units. Right? I need all possible units. Right? Then you have to make sure whether you have got all possible units. I don't know whether it's 2 or 3 or 4 or 5 or whatever it is, I need all. All means you need all. So start from the very beginning from the side and then break it down step by step. And then finally, if you ended up having fundamental units, which means you have covered them. Right? Okay. So I'll discuss this before the next class starts. This is the homework. Right? and keep some space there and look at the board again. Keep some space for this. Look at the board again. Listen. Listen, this is the last thing we'll be discussing today. This will be the last thing that we'll be discussing today. Right? Any questions? No? Okay. Right. As a topic, write down light years. As a topic, write down light years. Light years. Light years. Light years. Have you come across the word light years? No. After? That's a long year, not a light year. Huh? Yeah, that's a long year or a deep year. Have you come across the word light year? Come on, okay. Have you come across the word light years? If you ask someone who is interested about astronomy, astro things, you should have heard this light years. In astronomy, that is very much in use. No? Usually, distance to planets, stars, such things are measured in light years. Right? Right? As an example, if I need the distance from Sun to Earth, let's say, that's in light years. Right? The idea is this. Okay, even if you have heard about it before or not, that doesn't matter. Light year means light year. The idea is distance traveled by light per year. Light year, distance traveled by light per year is called a light year. Right? So therefore, it's a distance. Distance traveled by light per year is called a light year. Okay, write down below. Write down under the topic. Distance traveled by light. Distance traveled by light. Distance traveled by light. Online students, you are on track, right? Distance traveled by light per year. Per year. Distance traveled by light per year is called a light year. Distance traveled by light per year is called a light year. Okay. So first thing is, therefore it's a distance. Even though it says years, it's not having any time related meaning. That's about a distance. Right? The next thing is velocity of light. Now look at the board again. Anyone who knows velocity of light by any chance? Velocity of light. What's the velocity of light? Anyone who has heard about the velocity of light by any chance? What is velocity of light? Velocity of light is 3 times 10 to the power 8 n minus 1. A massive value. It's a massive value. 3 times 10 to the power 8 n minus 1. This much meters. 3 and 8 zeros after 3. Right? Meters per second. 3 times 10 to the power 8 meters per second. So this is called velocity of light. Right? Write this down and highlight this. No need. Not mandatory. I mean, if needed for you, that's fine. Not mandatory, but highlight this velocity of light. 3 times 10 to the power 8 times minus 1. Okay. Now we are going to find out the value of a light year, because light year is the distance traveled by light per year. Velocity of light is distance traveled by light per, per second. Right? Then we can convert this. We can convert this. Now, based on this, we can find the value of a light year. Look at the board. Light year. So this is the distance traveled by light per second. This is the distance traveled by light per second. That's the velocity. Velocity is the per second value. Right? Then 3 times 10 to the power 8. This is the distance traveled by light per second. This is per second. This is per second. Right? And if I need to convert this to a minute, 1 minute is 60 seconds now. So if this is multiplied with 60, this is the distance traveled by light up to here. This will be the distance traveled by light per minute. Right? Then if I convert this to an hour, again into 60. Right? Again this into 60. This into 60. This will be the distance traveled per year. Per hour. And if I need to convert this to per day, 24 hours per day. And if there is per year, 365 days per year. So there is this much of meters. No need to simplify this value. No need to simplify this value, but we have to know what the value is. Knowing the value means we have to know how the value derives. Right? You will get to derive this value. You will get questions to derive this value. No need to simplify it, just derive. So light year is distance traveled by light within the year. This is per second, per minute, per hour, per day, per year. Right? Any questions? Online students? Online students, any questions? Good. Okay, so therefore, right here is the unit of what? Right here is the unit of length. That's the unit of length. Now, since this is a massive value, that's why it is used to measure massive lengths. Now, distance from sun to earth is something massive, so that is measured in light years. Now, if we say that in meters or something, see how many numbers we are getting, right? See, is a 1 light year, no? Then easily we can say whether it's 2 light years, 3.5 light years, something like that. Then that's easy to use. So therefore, this is used to measure massive distances. Okay, write this down with a red pen. Write this down with a red pen. Therefore, light year is a measurement of, unit of. Therefore, light year. Therefore, light year. Therefore, light year is a unit of. Therefore, light year is a unit of length. Therefore, light year is a unit of length. Right? Therefore, light year is a unit of length. Therefore, light year is a unit of length. Okay. And now listen. Other than the given question in the note, right? Now we have to complete all parts in the tube 1, 2, and 3. I will be discussing all 3 before moving on to dimensions next day. Right? So these are the homeworks in the tube complete the question 1, question 2, and question. The questions are asked questions on the MCQs. There are 5 more questions on the MCQs, no? Right? That's 5 MCQs. That's all. Right? All 5. Right? So I hope it's clear. There are 4 more things to do as homework. First, I gave you a question in the theory book, complete it, and then in the tube, 1, 2, and MCQs. Right? 5 MCQs before dimensions, and I will discuss the answers of those MCQs on the next day. Sir? No. And I have put past papers in the back of the unit as well, right? We'll complete those past papers later, right? Those are not the past papers. Past paper questions are separately put at the back page or somewhere, right? Then we will see the past papers as well. Still, don't worry about the past paper questions because we just finished units only, right? And the next part coming up is, listen, next part coming up is dimensions, right? And that's the remaining part of units and dimensions. Once dimensions are finished, first subheading of first unit is finished. Second subheading will be measuring instruments, right? Okay, now this is where we are. Right, we started first unit and units in units. That's the first lesson in our syllabus last day, and now we have finished all parts to be discussed under units. Right, under units, everything is covered. Go through all these questions that are given to you. That's the first thing. The question that I gave in the notebook, theory book, right? Those are the homework. And other than that, from today, 2 free sessions are over. Right? Last one and the today's session was free. So 2 free sessions are over. And as I told you before, you can get yourself registered now. Right? If you are continuing the class, you can get yourself registered now. I'll share these links again in the community as well after the class. Right? lms.matlab.lk. This is the link you should navigate to and register yourself. Right? lms.matlab.lk. That should be the link that you should navigate to for your registrations, and in a lecture time you can register yourself freely. It doesn't matter. And if you got any questions, you can contact the hotline. I'll mention the hotline number here as well. This is the hotline number. You can contact this at any time. That doesn't matter. Right? Okay, this one 07797400171. That's a hotline number. So for any clarification, you can contact that number as well. Right? And if you need any technical support about the LMS or something, especially for online students, you can get it through this as well. Right? Anything, any assistance that you need. Because next week onwards, listen, next week onwards, you have to log into the class through LMS. Right? You have to go to your account, and there, if you registered once you purchase the class, you can see the class. Then you can go to physics. There, week 3 will be visible, something called week 3, week 3, and there will be button as let me show you. There will be a button to join the class. You can click on that button and join the class. Otherwise, in group or somewhere, the link will not be shared. I'll be showing it using the senior class. something like this. Uh, Likewise, you can see some weeks like week 1, week 2, week 3, week 4, something like that. And if that's week 3, go to week 3. Once you go to week 3, you can see start meeting, something like start meeting here. Your interface will be a bit different than mine. Yeah, you have more options, right? This one doesn't know. You have something like start meeting. Meeting or join the class. I can't remember the exact word you have in UNL. You have a green color button, as I can remember, as join class. Once you click on that, you will be directed to the class, right? So that's how it goes, right? Something like this, something like this. And in terms of technical support also, if you need anything, feel free to contact this for any technical support. Right? Since the next day is going to be the first day that you are using the LMS to join the class, sometimes you will get some doubts or technical difficulties, no, especially technical difficulties. So therefore, feel free to contact this number anytime. They will help you out with that technical aspect and everything. And if you have any doubts regarding the payments, right? This is the same number for everything: payments, registrations, technical support, anything. And if you need anything, if you need uh, anything directly from me, from my side, uh, you can contact me as well in the description. My number is there, and I'll drop this to the chat again, right? And you can see my number from the messages that I have sent to the chat, right? So that's my number. So you can contact me for any clarification if you need anything from me as well, right? Doesn't matter whether it's something regarding this or a subject matter, anything, right? All right. So then we'll be wrapping up the class from here. We'll be wrapping up the class from here. Make sure you are registered before next class. That will be 17th, right? Yeah, 17th. That will be 17th. Make sure you are registered before next class, because otherwise uh, you can't join it. You can't get the link actually. That's the thing. It cannot be done. That's not the shareable link. The link is only accessible using LMS, through LMS. That's how it works. Right? Okay. For physical students, that doesn't matter. You can come here and join the class. For online students, you have access to LMS. But for you, the registration is only through LMS. Right? Okay. Yeah. You are in the community, right? I can't remember. All right. All right. Then I'll wind up this here. That's it. Then, okay. Any questions before winding up? Anything to clarify? Now, most of the online students are already left. Anyway, for you, any questions? Anything to clarify? Online students, is it all good? Okay. Then that's it. I'll be wrapping up the session here. See you all in the next day, in the next class. Right? That's it. Goodbye.